Thank you. Over to you, Aditi and Ritika.
Thank you for your kind words, sir.
The Internet of Things, IoT, is becoming an increasingly growing topic, and it is a concept that has the potential to not only impact how we live, but also how we work. The reality is that IoT allows us for virtually endless opportunities, and it is not hard to see why or how it is such a hot topic nowadays.
To give us some insight on this topic, I would like to introduce our speaker for today, Mr. Amey Patkar. Mr. Amey is currently working as a systems engineer at TCS. He has a track record of understanding and translating technical requirements to improve system accuracy and reliability. He has experience in various programming languages like Java, Python, COBOL. He also has knowledge about HTML, CSS, JavaScript, PHP, SQL, etc. His academic projects include cursor control using eyeball movement, CO2 detection in mines, IoT-based alarm detection system, boutique management system, and many more like these. So, without wasting any more time, I would request Sir to start the session.
Thank you for the wonderful. I'm really sorry. The tab closed down. Yeah. Thank you for the wonderful introduction. So, as they suggested, IoT is a booming field right now. Everything from your phones to every small automated systems that you get, watering systems, or basically traffic light systems, auto management system, everything. The smallest thing that you can find is an example of an IoT. So, as Sir suggested, most of you present in the sessions have very few idea of what actually IoT is. So, to start with the basics, I would like to say that everything that includes technology has IoT in it. Consider the smallest thing. So, example, the most thing that you use, your telephones, your mobiles, they are a very advanced application of IoT. What do they include? There is a processor that processes the inputs and outputs. There is a battery that supports all the processes in it. So to let on the example of what IoT is, I will basically classify IoT into 5 parts. One is the power. To run any kind of application or any kind of electronic project, the most major thing that you need is power. Second thing would be the processing. Because if there is data available, then you need to take the input, process it, and then only give the output. That is what makes devices smarter. Third is the input. What inputs are? Inputs are basically the stimulations that we take from all their surroundings. Outputs. Outputs are majorly the changes that we do based on the processes that we have done. And fifth is the environment in which the system works. These are 5 major things included in IoT. If you are able to understand all these 5 things, then you can create any kind of project in IoT. So I'll give you a basic example of what IoT is and how you can do it is in TinkerCad. So consider a small object like a flashlight. Okay. So what would you consider as an input to a flashlight? The button on the flashlight that you use to turn it on is the input. You move the button to send a signal to indicate that you have to turn the flashlight on. This signal is processed and then the power is given to the light which generates the output. That is, it illuminates the room. That is also an example of IoT. So now talking about the program or the application that we are using for performing IoT. we are majorly focusing on an web-based software called TinkerCad. So what TinkerCad does is to give reference to similar applications, they would be WordPress. Then you have also Mobilize. So what these do is they help you make applications or web pages without actually knowing how the code behind works. Similar it is with TinkerCad. TinkerCad provides you a system that allows you to model live things online without actually knowing or understanding how the code behind it works. So basically, it is just a drag and drop system. What it does is, if once you do a basic circuit building, there are few controls on it. So I would like to ask permission to share my screen right now, if it's fine.
Yes, sir, you can do it.
Thank you. Okay, so is the screen visible, sir?
Yes, Amaya, screen is visible.
So as you can see, this is the basic screen of how TinkerCad looks when you log into it. So what are the various features that TinkerCad actually provides you? It is not just for circuit building. You can design 3D models, you can design circuits, you can design various code in TinkerCad. It supports a lot of things. But what majorly we want right now is the circuit parts. So let's just do what basic circuit and why to use TinkerCad. Okay. So consider this. You are currently performing an IoT project, and basic, you just have to light up an LED. That is the basic thing what you need to do. So as I said, what are the various things that we need to actually do this? So consider the 5 things: power source, output, input, the processing, and the last thing would be the environment. So to just light up an LED, what do you think there are 2 things we need? The power and the output source, that is the LED. So as you can see, this is the basic screen of how TinkerCad looks. I'll show you how and what each field available on the screen are. So if you can see on the left hand side, there's this option called rotate. What it does is, if you're dragging and dropping a component, it helps you align the component as per your needs. Then the side is a delete button. You can just select an item and delete it directly from here, or you can use the delete keyboard. This is also used for rotating. These are just for annotations. Like if you're building up a circuit and you need some comments behind a certain output or input sources, like if it is a potentiometer, then what kind of potential that we want to give. So all these can be commented on the circuit diagram using annotations. On the right hand side corner, if you see, there are components and there are various options that are included in components. So currently what we need is a power source and an LED. So let's just say so here's an LED. Okay, so it takes some time to load on the screen once you click it. So wait patiently for it, because sometimes what happens is we add too much together. Okay, so this is the LED, and here's a power source. That is the battery. As you can see, there are 2 kinds of wires coming out of the LED. What TinkerCad does is it allows you to actually see each LED. So you do not need to know what kind of wire should be joined to what part, because it defines each part. As you hover over it, it will show you what is what. So now we need to just connect this to the positive and this to the negative. So now if we run it, it should run, right? So take the fields on the top right corner. Test code, the start simulation, and there's export. Okay, so code part we'll come back to it later. So consider the start simulation part. What start simulation does is basically it just provides power to whatever circuit you have built. So let's start the simulation. It did not work. The LED bursted out. Why? If you want to know the reason, you just have to hover over it. It will tell you what is wrong with the circuit. So as you can see, the LED has the maximum voltage of 915 milliampere. What we need to do is to minimize the current that is going through the circuit to actually make the circuit work. But imagine if you were doing this directly in real life, you'd be wasting an LED. LED is still fine. Imagine wasting a Wi-Fi module. Imagine wasting a servo. These are expensive stuff. When you go to buy stuff, they are a minimum of 300 to 400 rupees. If you by mistake provide higher voltage or just turn up the potentials like negative and the positive and positive and negative, you will be wasting a lot of money in products. So what TinkerCad does is not only allows you to code easily, but also allows you a system that actually helps you simulate the code completely. So now, as we know that the current going through the LED is very high. And to avoid such high currents to pass through, we need a resistor. So what a resistor basically does is that it avoids very high voltage from going through. Okay, so let's just add this to the circuit. So as you can see, if you hover over, you can just drag the wire anywhere you want. But for understanding purposes, make sure that you always keep the wires either vertical, horizontal, or slanting at 45 degrees, because that makes the circuit very readable. Right now, there are just 2 to 3 wires in the circuit, but once you increase the wire system, what happens is you get really confused of what is what. So make sure that you always do it vertically and horizontally, or max to max in 45-degree angle. So now that this is the circuit, if we start the simulation, you can see that the LED glows up without any damage. So what is it is, we limited the amount of current passing through. So now the basic things that I would like to suggest you before you use TinkerCad. The basic thing is wires. Okay, so when you're connecting wires, TinkerCad basically gives you just green color in the beginning, but it is better to always color code your wires. The thing is, if you do not color code your wires, you will have wires going all over and you have to trace each wire where it goes. So before that happens, what you need is you need to actually know which color is for what. So we basically define 4 major colors in TinkerCad. One is the positive, second, the negative, third, the input, and fourth, the output. There are many other special wires that we need, but we do not currently need them. So these are 4 wires that we are going to use. So how do you change the color of a wire? So just click on it and you can just change. So for my convenience, I just always do the positive to red and the negative to black. So what it does is, whenever I see a red line or a black line, I know that this is a power. And once you know that how to trace a circuit, you can decode any circuit available. So let's just go a little bit complex on this. Okay. Now, majority of the circuits that you are going to build will be using an Arduino. What is a Arduino? So as I told, in IoT, there are 5 components. We saw the battery. We saw the output, that is the LED. The environment is basically where you are operating the system. Now let's come to the processing. So what is processing? Processing is when you take updates from the environment. You manipulate the data that is coming through it and provide some kind of an output. So let us see what an Arduino is. So here's an Arduino for an example. Okay. So what is an Arduino? Arduino in simple terms is a processor. It is a micro CPU. It takes an input, it processes it in its memory and provides you with an output. You can program it to do any kinds of stuff. Even very complex stuff, that projects that you're going to make are going to be very easy using an Arduino. So I'll explain you in short what various pins on an Arduino are. Okay, so as you can see, there are 13 pins on the top, which are named from 0 to 13. There is a ground, and below there are 5 A pins: V in, ground, 5 volts, 3.3 volts, and reset. Okay, so let us consider what these 0 to 13 pins are. These pins, if you hover over them, it will show you D0, D1 to D13. So what does D means? So these basically are digital pins. That means digital pins are pins that will give you output or input as 0 or 1. There is nothing in between. It's just 0 or 1. Then below there are analog pins. Sorry. So what analog pins does is give you analog or continuous data. As you know, analogous data goes from 0 to above 1000. So it's just a series from negative to positive. So these pins are used to read data that has a certain value. So if you consider that we are reading temperature right now, okay? So reading temperature cannot be 0 or 1. It has some kind of a value. Or if you're measuring a distance, so distance can be in centimeters, meters, inches. It cannot be 0 or 1. So these values are read with analog, and if you have to just check if there is something in front or there is not, like you are just checking if there is something. That means it can either be 1 or 0. There is something present or there is not something present. So let's see the basic example. Okay. So what if you want to start an LED using an Arduino? Let's take a breadboard for better understanding. So sometimes what happens is we usually do not know how the breadboard is connected in the back. What TinkerCad does is also helps you to know which point in the breadboard is connected to what point. So if you hover over, like see, this is the negative one. If you hover, you can see that all the negatives are connected to each other in a series. If you hover over the positives, then it will show you that all the positives are connected. Similarly, below, all the positives and negatives are connected to each other. The middle part, you can see if you hover, you get a green line indicating that this point is connected to all the 5 points below, be connected to 5 different points. So let's begin with an example, the same example. Okay, we have to lit up an LED. So yeah, let's just connect an LED over here. Okay. So now that the LED is connected, what we need is basically the power to it and the negative. So while connecting, always remember when you are using a breadboard for connections, always use these lower circuits for providing power. So as you can see over here, it provides you with 2 kinds of voltages, 3.3 volts and 5 volts. You can use them as per your needs. So let's connect the 5 volts first. And the ground goes into the negative. Okay. Now, what if I tell you that you need to not only use the circuits below, but above as well? So you need power to these. So you need to connect the positive to the positive and the negative to the negative. Always use these to connect further. So you can just connect the positive to the positive right through here. and the negative to the negative. So what this did is it just provided you power to the entire circuit. So as I suggested, always color code everything. That helps you understand what is going on in the circuit. Not just you, but you are going to present this project or the code to someone else. There'll be an external examiner who will be understanding your projects. So if your circuit diagram is properly color coded, it will help them a lot. Okay, so let's just connect this directly. So directly negative to negative and positive to positive. But this wouldn't work, as we know. We checked that 5 volts provides a very large current to the LED. So if we run it right now, the LED will burn up. So we just remove this. We add in a resistor. Okay. And now we connect it directly through the resistor. So now when you run the code, what happens is it inserts and provides power. Now why did it break? Any ideas? So what happened is the circuit we are providing right now over here is unable to completely take off the current. That is the reason the circuit or the basic LED broke down. And always remember, if you have to do any changes to your circuit or diagram, anything, you always need to stop the simulation before you do anything else. Always stop your simulation and then only visit or do any alterations to the code. So without wasting any further time on these basic circuits, let us take an example of a circuit that not only includes the input and output, but also things that we can analyze from the environment. Okay. So majorly what your projects regarding IoT will be revolving around sensors and actuators. So what are sensors and actuators? So as I said, 5 components, just 5. The inputs that you get from sensors. So what sensors do? Sensors sense the environment, produces some kind of a digital signal and gives it to your processor. These are sensors. What are actuators? Actuators are actually things like LED. LED is also an actuator. What it does, it does some kind of change in the environment upon the outputs that you provide to it. So if you consider LED, the light that it produces is a change in the environment. So whichever object or instrument that changes the environment is an actuator. So let us take a basic example of what actuators are. Major things that you're going to be using right now are all the things that you see here. Okay, so consider that you have a project wherein you have to alter or pulsate a doorknob. Okay, so you need to open a doorknob every 5 seconds or every 10 seconds. So you need to rotate the doorknob and get it back to its original place, then wait, then again rotate and get it back to its original place. That is the job you have been given. So rotation, if you have to rotate something, you need a motor. So what a motor does is just converts electrical energy into mechanical energy, that is rotational energy. So if you go down there, there is a DC motor that you can use or a micro servo. So what a DC motor is, it is a continuous motion which is not controlled. You cannot control the angle or how much you want to rotate. But a servo, it is also a motor, but what it does is it helps you to rotate at a specific angle or in a controlled way. So what we can do is, if for a doorknob we do not need continuous rotation, we need a controlled motion. So what we use is we use a servo. Okay. So let's just place our servo. So you do not know, like let's just consider even we do not know any kinds of connections that are provided that we need to do for a servo. It's new to us. So how do you know which is what? You just hover over it, we'll get this is the ground. So this should go in the negative. Okay. So it went into the negative. Now always remember, whenever you connect, always color code it. Second is the power. You provide it to power. Now that you have connected it, the servo has power. But what do you need? You need to signal the servo to start its motion. How do you signal the servo? So now understand what is your requirement before doing anything. To indicate a servo to go on or off has just two states, on or off. Which kind of pin do you consider we should be using? There are two pins, analogs and digitals. The analog pins provides a continuous output. Digital just provides 1 or 0. Currently, our requirement is just a two-state system that gives on or off. So that is the reason we are currently using digital pins. So what does digital pins over here do is they just provide you with on or off options like 0 or 1. It is a signal. If it's 1, then the system should activate whatever programming you have been doing. Okay, so let's just consider we use the pin number 2. So we take the input and we connect it to the pin number 2. Pin number 2 is not working for some reason. It's directly connected to pin number 7. Okay, so let's consider that we are using pin number 7 for a reason. Okay. So now if you see, now we can see that the angle of the wire right now is not how we want it. So what we need to do is just need to hold and pull. See, that helps you complete the wire in vertical and horizontal motion. So now what we need is we need the output from D7. The 7th pin in the Arduino should fire 0 or 1 to indicate this servo to either rotate left or right. Okay. So how do we do that? How do we program the Arduino? So here there's an option called code. Okay. So if you open code, you get a basic simulation or basic code. Let's just forget it for now. Okay. So as you can see, they have given you easy blocks. You can also use the option of text coding if you want. Okay, so what this does is it just provides you with the direct code in which you can do the actual coding. But currently our system, what we need is we need a precise system or a way in which we can do coding easily without actually doing any kind of coding. I can guarantee you that any kind of project that you're going to make in your entire IoT can be done using a normal TinkerCad simulator. Any kind. I'll give you some examples in the end when we're about to finish. So let's just say that this is the servo. Okay. So you need to do some kind of output, right? So when you have to rotate the servo. So that is an output that you're giving to the world. So if you check in servo, you can check, see, there's a servo over here, right? So if you just select servo, okay, so it takes some things, right? So rotate servo on pin. So which pin is the servo connected currently on? So we have connected the servo currently at pin number 7. So we need to see what kind of output is given on pin number 7. Okay, and how much do you want it to rotate? We want to rotate it to suppose 180 degrees. You can provide any kind of angle you want. It's like if you want to rotate it at some precise angle, like 75 or 30 or 45. I'll give you an example in which you will actually need a servo to work. Okay, so now how does it know that it has to read pin number 7? We have not mentioned it anywhere. So what basically we need to do is, as we do in other coding languages like Java or C, we need variables. So what these variables do is they basically store the value that a sensor gives you. So you need to create a variable. So we can just name it input. So now that you've created a variable, it will give you options what to do with the variable. Okay. So what we need to do is we need to set a variable. What setting means is you just equating the variable to a value. Okay. So let's just forget this for now. We take this, that is, it sets a value. Now it is setting a value, but what it's reading, what is it reading? 0. It is reading a number. We can provide any kind of number, but do we want that? No, we do not want input to read number directly. What we want it to take input from the surrounding or the environment. So where is that? Where can you get input from the environment? So there's a tab called inputs. It includes all the inputs where you can take from input from. So currently, where is the input coming from? Currently, the input is coming from the pin number 7. Okay, that is, it is giving out. It is giving 0 or 1. So if we consider this 0 or 1, we need to read this digital pin. What it is doing. Okay, so once you read it, it will give you some kind of an output 0 or 1. Now let's consider this. Just a minute. Yeah. What this does is it will set input to 0 and 1. Now what you can do is you can actually observe this pin will generate some kind of a value, that is 1 or 0. Once it generates the value, what will happen is the servo will actually rotate. By how much? By 180 degrees. So do you want it to just rotate at 180 degrees and stop? So thing is, no. You want it to alter between rotating left and rotating right. So what is that? You're trying to control how the system will work out. So it will come under controls. So what controls will do is it will give you basically if-else conditions. So what these if-else conditions do? The if-else conditions will just observe how the system works, monitor it, and then give output based on certain conditions. So what happened is you read the circuit, okay? You got the output from pin number 7. You rotated it to 180 degrees. Then what you need is you need to wait for some time. We need to give it time. Okay, so we waited for 8 seconds. 8 seconds will be too much. Let's just say we waited for 4 seconds. Then what we want is we want to rotate it back to 0 degrees because we want a motion like this and then back to 0. So again, we go over here, we take rotate servo. Now which pin is the servo connected to? The 7th pin. And where do we want it back to? We want it back to 0. After we have it to 0, we also want to wait for some time, right? Give it time to settle out. And here we can give the time of how much you want to settle it out. So what this code will do, this is a basic code that you have done. What this code will do is it will basically take the input from pin 7. It will see if it is 0 or 1. If it is 1, then it will rotate it to 180 degrees. Then it will turn it back to 0. Okay, so let's just start the simulation. So as you can see, as we started the simulation, it turned the servo motor. It waited for 4 seconds, then it turned it back on. It will again wait for 4 seconds, turn it to left, then again wait and again turn it to right. So what is it doing is pulsating the signal. So if you do not want a servo here, if you want to pulsate a light, basically the blinking light that you give can be done using this. What you have to do is you just have to give output to a certain pin. That pin will take the output. You have to wait, then change the output. So digital pins output can be changed from 0 to 1 back to 0. So this is how you signal. But now what you need is, you have made the circuit, you have made all the connections, you have done everything, you have done the coding, but you cannot add this to your Arduino, right? You cannot add this. You basically need a coding system that you need to upload to your Arduino code. So what you need now, you need the code in a different form. You need the code in text format. So what you need to do is just click on blocks and text. So what this will do is, this will convert all the block code that you have done into an Arduino code. So see, this is the simple Arduino code that it has done. It converted whatever code you have done in block format into this. So you do not actually need to completely code. Now you do not need to know what this does. You do not need to know what this does. Basically, I'll explain you what this does right now, but still, okay. So let's include this. What is this first statement that you see? This first statement is an include statement. So if you have all studied C++ or C, you know why we use hash include. Hash include is basically used to include various libraries that are present, and then int input. This is basically just an initialization. This is also an initialization. We are initializing the servo as servo 7. We are giving the servo a name that we can use further in the code. Here we are setting pins. So what do you mean by setting pins? Okay, so as I said, there are digital pins and then there are analog pins. So how does the Arduino know that you have to read from it or give output to it? Okay, you do not know. The Arduino doesn't know. So you tell the Arduino that this pin is supposed to read input. This pin is not supposed to do anything else but just read input. Then servo attached. Now what does this does is it initializes the servo mode. What do you mean by initialize? Okay, so let's just know what basics are. This 7 is the pin at which we have connected the servo motor to. We need to inform the servo that it has the input that it is going to get, whether to fire or not to fire, will come from 7. So this all comes under void setup. So what is setup? Basically, void setup is used to initialize everything that you are going to do in the code. And what is going to happen in the code will come under void loop. So if you look at the name of the code, loop, what loop means is it is always going to do everything in it again and again. It's not going to stop. So imagine if you are reading a sensor input and you just write read sensor and then print sensor output. So you are printing sensor output, that's it, the project stops. You do not want that with an Arduino or IoT project. You want it to continuously read the inputs and outputs that are coming out of the system. So what it does is constantly loops whatever code you have done so that the system is constantly operated whenever it gets power. So here we are taking the value of the input. So what does digital read means? Digital read is basically just taking the input from the environmental surrounding. Digital read gives you either 0 or 1. If you convert this digital read analog right now, like input is equal to analog. So what this will do is it will read analog input rather than digital input. That is from, it will be a continuous input. Then write servo.write. Okay. So .write is used for anything. Like if you want to print anything, you just write servo.write or basically serial.write. Now what serial is, I'll come to it in a few minutes. Okay. Then as you can see, he gave a delay of 4 seconds. In Arduino, there is no direct conversion of, like, if you can not directly give seconds. So we need to give milliseconds. So always remember, whatever seconds you want the Arduino to stop into 1000, and that will give you the amount of milliseconds that need to be added into delay or any kind of waiting thing that you need to do. Then we again write the servo to 0. So what this does is, if the servo is basically at 0th position, you start the servo and move it to 180 degrees. Then you wait. Then you again command it to go back. And again wait for 4. This is the basic code. But always remember, once you get the text code and you're going back to blocks, it will remove the code. It will not retain the code. So if you want, you do this only after the complete code is being done. Do not switch from text to block in between, because what it will do is it will just take away all your code and give it back to the initially where you were. So now whatever coding you have done before that is all gone. So always remember, conversion from block to text should be done at the end when your project is completely ready, and all you want to do is just give outputs. Okay, so let's just go back to the screen. So now that you know the basics of what IoT is and what kind of projects you can do, here you can see below, there are all the example of circuits that I have done. So these are the circuits. It's not complex, basically. It's just basic circuits. Now consider any kind of project, any. So if you are doing a gas detection project, okay? So you want to detect gas. Now, if you have to detect gas, then there has to be some kind of sensor that detects it, right? So it is known as a gas sensor. So what a gas sensor does is it basically senses the gas. It will give you a certain kind of value. You analyze what the value is and you give some kind of a number. Okay, a gas sensor. Now with gas sensor also you can do multiple projects like CO2 detection in mines, or harmful gas detection in household, or methane detection. There are various gas sensors. The most commonly used gas sensor is MQ2. This gas sensor can detect smoke. It can detect fires. It can detect multiple things. If you combine the smoke sensor or the gas sensor with the temperature sensor, you can make a fire detection system. If you want to just detect harmful gases, then just code it, give it a certain threshold value. After the threshold value, it will give you an output. Now, if you consider this is a basic circuit that I have built up so that we don't waste much time. Okay. So this is the basic circuit. So if you do not know what this is an ultrasonic sensor. So what does an ultrasonic sensor do? An ultrasonic sensor is a sensor that senses the distance between objects. So if you want to make a car parking system, okay, so there is a car parking system that you want to make, that if the car is near a certain object, like if the car comes in, the shed should open up and allow the car to go out. So if you want to automate that process, you don't want a man to come and press a button and then the lever goes up and then the car passes in. You want an automated system. So this sensor will help you build that. Now let's see how. Okay. So let's go into the code part. It's a little complex, but not as much. I'll explain you what it does. Okay. So if you see right now in the code part, these are just comments. So what these comments do is it help you understand the circuit better or the code better. So you can get those comments under notations. So what comments or notations are basically used is similar to the other coding languages. Okay. So let's see now what I have done in the code. Now, to check what coding has been done, always start with what kinds of inputs are being given or what kinds of variables are being given. So if you consider there are two variables, centimeters and inches. Now, why do we need centimeters and inches? So basically, this code will just calculate all the distance, convert it to centimeters and inches, and then give you an output. That is all this code is doing. So if there are two variables, there must be something that is giving it value. So as we saw before, the variables need to be set. That means they need to be given a value. So if you see, I have set centimeters to what? So we are taking input from something, right? So where is input? In the input field. So what do you need to read input from? You need to know what you need to read input from. You need to read input from an ultrasonic sensor. So here there are directly options available. You can see right here, read ultrasonic distance. So what this does is it will directly write a code to read the ultrasonic inputs from the whichever pin you have attached it. So currently, if you see, I have attached the input pin this to 7. So what this does is it will read the input from this, it will provide it to 7, and then we can use this 7 to do anything we want. Okay, so let's just see over here in the code. Okay, so now what we did is we read the input from pin number 7 where we have connected the Arduino, where we have connected the ultrasonic sensor, and echo pin. Now what is echo pin? Echo pin is basically where you are gonna get the output. That is same as pin number 7. Okay, you get the output as wherever it is connected to the system. This is the echo pin. Wherever the input is the output. Then what we are doing is setting inches. Basically, setting inches is we are just converting centimeters to inches. Now, what is this green spot that you see? Green spot is basically math. Now, what is math? You need to perform some kind of calculations. You need to perform loops. You need to perform anything that is mathematical related. You need to find it right over here. So I'll give you an example. If you want to do any kind of arithmetic information, so okay, we just drag and drop this over here. Now, what do you want to do arithmetic? Which kind of operation would you want to perform? Addition, subtraction, multiplication, division, modulus, raise to, whatever. All the stuff that you can do in coding can be directly done using drag and drop. So you do not actually need to do the complete coding of the system. So let's just keep this aside for now. So what I've basically done is just converted whatever we are getting in centimeters into inches by dividing centimeters by 2.54, which is basically the unit of conversion from centimeters to inches. Then you can see something new here, print to serial monitor. Okay, so what is serial monitor? So serial monitor is something you see down here. Okay? Whenever you write a code, you need to see what output does it give. So you, if you're doing C++, you write printf statement. Why do you write a printf statement? So the printf statement tells you what the input the system is giving and what kind of output is needed. So whatever the output, you print it so that you know what is the output. Now in an Arduino, you do not know how to print an output, or it is just a hardware. So what you do is you use a serial monitor. So this serial monitor will print anything you put in it. Okay. So where you find it, this printing is basically a output. So where you will find outputs in outputs. If you go down here, you will see there is a option for print serial. Okay. So currently it says hello world. The first program that you do anywhere in any kind of coding language is hello. So if you just put this print serial monitor hello world, what this will do is it will continuously print hello world. Now why will it do it continuously? As I told you before, there is something called as void loop. So what this void loop does is it does whatever you have given in the system in a loop. So if you just, even if you put this one statement, print print hello world, it will continuously print hello world until and unless the code is being run. Okay, so what we have done is we have just basically printed the value of inches. Where is the value of inches? It is stored in here. If you want to access, manipulate, change, whatever variable changes you need to do can be done right from here, from the variables tab. Okay, so you drag and drop variables into this, and that's it. The value of inches is now given to the serial monitor, and it will print it. Now, what is this without and with? So, do you know in C we use \n? So what this \n do is it just brings the system to a new line. Similarly, we are doing here. So if you do not put \n, it will print everything in the same line. If you use \n, it will print it on a new line. So similarly, you want to print something on serial monitor without using new line, and you want to print something with the value with a new line. Okay. So now that the code has been explained, it's a very basic code. We'll modify it ahead, but let's see what this code does right now. Okay. So let's just start the simulation. So once you start the simulation, you can see that the ultrasonic sensor has some kind of thing. In a hard world, like in a hard-coded world where you can actually have the ultrasonic sensor in your hand, you can put something in front of it. But when you're doing it virtually, there's nothing that you can put it on. So now what you need to do is you need to observe what kind of output you're getting whenever you move it close or you move it far. Okay. So you go into code and there is the serial monitor. So as you can see, it's printing something. So what is it printing? It's printing the distance in inches and it's printing the distance in centimeters after every 100 milliseconds. Okay. So let's just go over here. And if we change the distance right now, okay. So if you see the serial monitor right now, it's reading 88 inches. So if you move it closer, the distance will reduce and it will keep reducing. Okay. So whenever something approaches in between here, it will do some kind of motion. This is an example, but let's just use this example to make an actual project. Okay. This is now a system that reads whether something is coming. So let's just consider it is placed in front of a car parking system. Okay. And you need to open the gates whenever the car passes through it. So as I said before, if you want to actually move something in a controlled manner, you need a servo motor. So what it does, it opens up things or turns up things in a certain angle. So if you consider a door, it is always at 0 degrees. When you want to open that, just because 90 degrees, you pass and it turns down, right? That is basically how it works. So let's take a servo motor. Okay. So this servo motor over here will resemble our door. How the door should open. So let's just start. This is the ground. So you connect this to ground. Always remember, only move in vertical or horizontal for your better understanding. Okay. So now that it has been given power, we need some kind of output to it, right? You need to signal it that if this sensor senses some value, then you move. Okay, so what we need is we'll give it a digital output, whether it is 0 or 1, when it should move. Now it is connected. So whatever signal we are going to give at pin 8 will indicate this so that it should move up or down. So let's go into the code. So what does the code do right now? It just takes input. It does not perform anything. What we need is we need it to perform. We need it to do something when the car comes. So we need a condition. What is a condition? A condition is something that tells you if the car comes into the range, it should open up. If the car goes out of the range, it should close it. Okay. So let's just see controls. Now there are two options. If you want to just perform something, basically if and else. So if the car is present, then it should open the door. If else, it should close the door. That is the basic condition that we are going to use. Okay. So let's just say that we have added the condition. Now it needs some kind of calculation. So what this symbol this is it needs something in it. What does it need? It needs comparison between two things. Because as you know, if takes a Boolean value, that is, it can be either true or it can be false. So if you see here, we add this to this. Basically, this created an if-else condition in between. So if the distance of the car, that is, we just consider it in inches, is less than a threshold value. What is a threshold value? Less than or equal to threshold value. Threshold value is when the car is very near to us. So if for that you need to observe the inputs that you are getting here. So how much distance do you want the car to be close to the door for the door to open? So let's consider if the car is around 44 meters, right? So it is 44 inches. So let's just try to 44. So when the car is at a distance of 44 from the actual circuit, the door should open up. So opening of a door, what is it? Opening of a door is a output. So you need to do some kind of output. What do you want to do? You want to rotate the servo. Okay, so you write rotation of servo. Where is the servo connected? Servo is connected at pin 8. And how much do you want it to rotate? You want it to rotate to 90 degrees. Okay. Now, as soon as it rotates 90 degrees, you want to close it? No, you want to give the car time to pass through. So you give the car its time. You want to give the car at least, like, for now, for purposes, we are giving it 4 seconds, but it will be more, right? So it will be 90 degrees. Else, if this is greater than, okay, if it is greater than 44, then it should not open. So what will happen then is, else part, it should do something. What it should do? It should set the 8 pin. What is the 8 pin? The servo back to 0 degrees. And again, wait. This time waiting will be very less because you do not want it to set to be 0 and then wait and wait and wait for 4 seconds, 5 seconds for reading the next input. Okay. So that's it. This is the basic code. So let's just start the simulation. So currently, yeah, so it is 0 centimeters. Because you have not currently set in any kind of values. Just a minute. 0. It can be bugs sometimes, and it's always remember that. Red pin number 7. Yeah, setting it in centimeters, then setting the pins, printing it out, checking if inches is less than 44. Yeah, this. Hmm, that seems to be some kind of bug in the system right now. Just a minute, guys. I'll just check it out. What the bug or problem is. So set the values. Check inches. If the inches is more, then it should work. Yeah, there is some kind of bug in the system. Yeah, it's currently not reading any kind of input from the system, even though every connection is right. This happens sometimes. Which I'll just reload everything and we'll see. Oh, this is not. It's yeah. So let's go ahead and check. It's working right now. Just a minute, guys. I'll just check this out. This seems to be working. Yeah, there was some kind of bug in the system, guys. So let's just see this. So we add in inches over here and we compare the inches to 44. So if it is less than 44, then you should print high. That is basically you need to give some kind of an output. So for that, our output was the servo. We have not currently added in the servo. Let's just add the servo in. Let's just test it out that it's still working. Yeah, it's still working. Then coding part. Okay. If it is inches are less than 44, output rotate 10 to 90 degrees. Wait. 2 seconds. And then rotate it back to 0. Yeah, there has a problem with the system. It does not read any kind of input whenever the system has been provided with this. Let's just this. Now it's reading. Just give me a minute, guys. I need to figure this out why this is not working, because whenever you try it, you need to know why. Okay. Now it's working. Okay. So if you see this now, that the servo is not, like, it's not on, but whenever this will come inside the range of 45, the servo angle will change. See, now the gate is open. So if the car goes away from it, the gate will close it. So once you consider that this circle is the car, it is coming in, and as soon as it comes under the range of 40 inches or 44 inches, you can see the inches printed on the Arduino. So now it's 47, but not 44. Once it reaches below 44, the gate opens up, the car passes through, and then the gate will close in again. So this is a basic automated door system. It's a very easy system. You do not need any kind of higher knowledge for it. You do not need anything. Now, once that this is done, your code, you have tested your code, it's running. So that the car comes in, the door opens up, the car goes through, the door closes. Now what you need is you need to upload the code. So what you need is, now the code is in blocks. First, you need to stop simulation before doing any changes, always remember. So once the code is ready, now what you need is to convert the code in text format. Okay. So what this will do is this will give you a complete code. It might look complex right now, but it is very easy if you know a basic knowledge of what C is. Okay. So this is ultrasonic sensor function. Okay. So what it does is it takes in the input from the trigger pin and the echo pin. The trigger pin is the output. As we said, the pin number 10 that we have attached, the trigger in the blocks as we saw, is the output. Now we write digital this to low and wait for 2 microseconds. Then we write trigger pin to high, trigger pin to low. What this does is it gives them a binary signal. This will basically what it does is it just sends a signal out to a wall. The wall receives the signal and then it comes back. Similar thing happens. Okay, so what it does is it just takes the ultrasonic signal, processes it, and understands what is to be done. You do not need to code this. This is already an inbuilt function. Whenever you take in or hash include this can be easily done. You do not need to know how this works or what this does. Okay. So now what you do is, this is an inbuilt function. You do not need to code this. You can directly get. So you get this distance from this. So what is this? These are, we are giving the pins, like both the echo and the other pin, the trigger pin, both are set to 7. So when you give this will generate the distance between whatever the object is coming, and that distance is given into centimeters. This is basically just the conversion. It gives you a value to convert the output of this value into centimeters. You need to do some kind of conversion. This is done by this. Okay. This is basically the time. What is ping time? Ping time is basically the amount of time the sound that this has produced to hit the wall or hit the object in front and come back. That time is used and to calculate what is the distance between the object that is coming in. As you know, speed is equal to distance upon time. You know the speed of the sound, you know the time that it took, so you can calculate the distance. That is what it does. This calculates the distance, and then we use this to convert it into centimeters. So this is also same thing. You convert centimeters into inches. You print it serial.print, as I suggested. If you want to print anything on this serial monitor, you use serial.print. Serial.print is used to print on serial monitor. Okay. Now, if inches is less than 44, same thing. If look that we get, then write servo.write, give server 90 degrees, so it rotates to 90 degrees. Wait for 2 seconds, else write servo to 0 degrees, and then wait for 100 milliseconds, and then read input again. This is a very basic tool, but can be converted into a mini project very easy. Okay. So now what people will say is that we are not using a single Arduino. We are using 2 Arduinos. We are using Bluetooth system to actually communicate using Bluetooth. What if I tell you do not need to change anything in the code to make it compatible with Bluetooth? If you upload the same code directly to your Arduino using directly to your Arduino and connect it to Bluetooth with master-slave connection, you actually do not need to change a single thing in the code. This will work on a Bluetooth connected system. I'll tell you how. You know this serial.begin 900. What this is doing is this is basically making a connection over this wave. So both the code. This is so if you just remove this servo motor. If you remove the servo motor, attach this servo motor to another Arduino, which is connected to Bluetooth. So what this serial.write will do is it will send whatever output you are getting in the serial monitor. This through a serial connection between Bluetooth to the other Arduino that is connected to. Whatever code you have given here, this, if you just copy this code, put it in the receiver side, then this will work on a master-slave Bluetooth connection. You do not need to change anything. Okay, so this is how basically you can make every project using Arduino. So if you if you want to connect something like fire detection system, okay? So what is basically a fire detection system? It's basically two things: smoke detection system and a temperature detection system with a servo. What does the servo do? It just opens up the water outlets that are present on top. So I'll show you an example of a basic gas detection system that I have built up to show you. So at times, this might look complex to you, like very something that should not be present, but it is actually not that complex. Okay. So what do you think this does? Basically, just too much things that are not to be needed. But what this does is it senses the gas, it generates alarms, that is the light alarm as well as the sound alarm. And what is this? Why is there a servo motor? Okay. So I'll explain you what this project or this circuit is. Consider you are making a harmful gas detection system in a mine where there are lakhs of workers working around. And in a mine, when there is a harmful gas leak, there are still people down in those mines. You just don't need to warn them that there is a very high toxicity level. You also need to tell them you need to run and there needs some time. So this basically servo motor represents a valve that is connected to a reserve oxygen cylinder. So when the levels of gases become too much to bear, what we are making servo motor to spin. That is the valve of what this will do is it will provide you with free flow of oxygen so that the people trapped inside can get some time to move on. Okay, so let's just do a basic simulation of what this code has. So this is the gas cloud, okay, that is going around. So whenever it senses it, see what it did. It just sends that there is a gas cloud around. It raised an alarm, and it gave out a signal. So now that we are moving around, it see now the gas valve is also off, so that there is no oxygen wasted. Like if the toxicity level, the darkness of the cloud represents the toxicity level around. So this okay, but if the toxicity level starts increasing, then you need to warn the people and you need the very high flow of oxygen in. Okay. So first you warn people. First you not directly give oxygen. First you warn people. But if now you're warning people, now the flow is not that much. But once the flow increases even more, now just warning won't help. So now what you do is you turn on the oxygen. That will help and give people time. This is a basic project that will help you to analyze what can you do with TinkerCad. That's all from my side for today. But there's just one thing I would like to add to it. If any further things you want to analyze the input, like currently, if you see the serial monitor, you're getting some kind of output here, right? The sensor is giving the value. If you want to analyze this value, like just take this example only, if it's mines, you need to analyze something. What is the time when the gases, your toxicity level in the mine is very high? That is, if you consider in the afternoon, the gases rise up and it is very risky for the people. But you need solid proof of that. So what you do is you analyze whatever output is coming from it, and you try to find a pattern. This pattern will help you and tell you that at this particular point of time, entering the mines is very risky. Now, how do you analyze it? Just using TinkerCad. You do not have any kind of system. Like you do not have an Arduino, you do not have it. How do you analyze? There is an online website called ThinkSpeak. So what this ThinkSpeak does is, whenever you connect this to ThinkSpeak, it will throw all your sensor outputs directly onto ThinkSpeak, where you can do analysis on the output. So if you want to continue your project even further and do analysis on the outputs directly through TinkerCAD without wasting or using money on buying products, you can do it directly to ThinkSpeak. You do not actually need to connect it to a database or Firebase, then get the outputs, do perform analysis separately, and then provide output. You can directly do everything online using ThinkSpeak. So that would be all from my side. If there are any doubts, please do ask.
Okay, so participants, you can ask your questions in the chat section.
Okay, so how can you send data on a web page? Basically, if you there is just two-line code. Okay, so what you need to do is you need to connect your Arduino model system through a Wi-Fi module. You can get the Wi-Fi module on the directly in TinkerCAD. The connections are directly made. You can get a pre-designed system that is available. There are some pre-designed systems. I'll show it to you if you want. Okay, so if you go in TinkerCAD, right here, and you go into Arduinos. So here you will find basic structures of it. So you will get a Wi-Fi module structure available right here. If not, you can just search online. There are already connected Wi-Fi modules available. In that, you just need to add the page. Like if you don't know if you can see this my screen directly. Yeah, things. So this is the basic platform, ThinkSpeak, that helps you analyzing it. Okay. So what you do is it's free. You can just directly use it. Then you write it here. Now I have not yet initialized here, but once you log in, you can generate a key. You use that key and you put that key directly in your uh, connection. Like how you send data through Bluetooth, that is through serial.write, serial.print. What it does is it sends data on the serial monitor. Serial.write sends data over Bluetooth. So similarly, serial.write can send data through the key. You have to mention the key that you get through ThinkSpeak. So what this will do is it will send whatever data you're doing analysis directly to ThinkSpeak, where you can actually analyze what this data is. So this is the website. If anyone wants it, you can use this directly. All the projects can be done using Arduino. basically the amount of pins you need define which kind of Arduino you need. You can do all the Arduino projects of Uno using Nano. You can do all the projects of this using a Mega. But it all depends of what is your pin requirement, what is the system. But all basic projects, everything that are available, you can easily do using Arduino Uno. You do not need an expensive or higher version of Arduino for doing any basic projects. Are there any other doubts?
Any more doubts? Anybody?
Simple projects using Arduino. Okay. A lot of projects that you can do that are very simple. Fire detection system, smoke detection system, car parking system. Then there are other basic simple projects like irrigation system, automation system. Then there are also some other projects like light detection system, or if the automated light system that it will sense the light that is coming on, and you can using the amount of light that is coming through, you can detect whether you should turn on the street lights or you should not turn on the street lights. Whatever, these are the very basic projects that you can do that require just one sensor. Or you want to make a very basic and simple example, but a very high-end project that you can do is a automated mart project. So see, consider if you have a bucket, okay, and in that bucket, if you have some vegetables, like if you have consider onions, okay. So if you have onions and your onions are reducing in amount, but you need to order them online directly, you do not need to interfere. So what you need is you need a force sensor or pressure sensor just down. What it will do is it will sense what is the weight of the onions on top of it. Once the weight of the onions reduces by a certain threshold value, you know that the amount of onions you have is very less. So as you can see, you can connect to ThinkSpeak, you can directly get the data. Once you get the data, you can directly send it an SMS. You get an SMS module, or it's also called a GSM module. The GSM module, you can program it to send SMSs. So once you know that this onion or this quantity is less, you can SMS directly to the vendor to order a certain amount of onions you want, and the vendor can directly provide it to you. That is an automation project you can do easily. It's very inexpensive and easy to do. Any more doubts?
Any more questions, participants?
Yes, it is possible to directly load the code from TinkerCad to Arduino. As I told you, once you write the complete code, you can convert the block code into text code. You just copy that code directly from TinkerCad, paste it in your Arduino, and upload it to your Arduino. That will work directly. You do not need to do any kind of other coding or changes to your code. It will directly work with Arduino as well. Any more doubts? If you have any kinds of queries even further ahead, you can directly take my number from Vivian sir or someone and directly contact me. I'll help you anytime you need it. It's a IoT is very easy, and most of the things that you are going to use are already available on TinkerCad. So gas sensor, you search for a gas sensor, you will get it. You search for a distance sensor, you will get it. So you do not need to actually go deep into it. You need to understand what the code is doing, modify the changes that you need, and then use the same code directly into your actual hardware project to make a project. It's very easy. IoT is one of the easiest projects or subjects you will ever do.
So I guess participants do not have any questions further. So Ritika, we can proceed further with the conclusion and vote of thanks.
Since all the queries have been answered, as we come to an end of our event, on behalf of the entire organizing team and all the participants, I would like to extend a heartfelt thanks to our distinguished speaker, Mr. Amay Patkar. It was a thought-provoking and a very well presented hands-on session, sir. So thank you for that. Along with this, I would like to extend a thank you to our HOD of the IT department, Mrs. Anita Chaudhary ma'am, for her presence in this entire seminar. As no event can be successful with just one single person, it is a big thanks to the entire SPCA team, along with the CSI SJCEM student chapter for organizing such an informative event for all of us. Finally, all the wonderful participants who have turned up today, despite it being a Sunday. For thank you, participants, for your cooperation. If you want to know about further such interesting seminars, you can follow our Instagram page and subscribe to our YouTube channel. So I once again thank everyone for attending this seminar. Now, I request all the participants to please switch on their camera since we need to take a group photo.
Requesting all the participants to kindly switch on their cameras so that we can have a group photo for today's hands-on session.
Done.
I guess the group photo has been done.
Kritik's done. Done, sir.
Okay, fine. Aditi and Ritika, over to you for furnishing the last instructions.
That's it, sir. The participants can leave the meeting. Also, they need to fill the feedback form that has been posted into the chat box.
So participants, please do give your valuable feedback for the session, and the link would be deactivated for the feedback by 3 p.m. So ensure that you fill the feedback forms, because once you fill the feedback forms, then only the e-certificates will be mailed to you on your registered email ID. And please do like, share our YouTube page of SPCA as well as CSI student chapter of St. John College of Engineering and Management. And at the same time, do follow our Instagram page of CSI as well as SPCA. So I, on behalf of the entire team, the organizing team, the students, as well as the faculty coordinators, wish you all a very great day ahead. And I hope you all have enjoyed the session. Thank you so much for joining, and I look forward your active participation in our future events also. Thank you and have a great day.